most famous names that we know. He was born into a local Mongolian family and later controlled probably the biggest empire that we have ever seen. The Mongol Empire stretched over most of Asia and almost all the way to the edges of Europe. So how did a group of nomads manage to conquer so much land and defeat army after army? It seems that many things played a role in Genghis's victories. For example, the saddle and the war tactics that they used. But one of the most important parts of their success was due to the bow and arrow. They didn't use the bow the British used, nor the bow that the American Indians used. The Mongolian bow was different from most bows and had several advantages over them. They also had different types of arrows for different situations.
The composite bow can easily be identified by its recurved structure. The old Mongolians lived in an environment where survival skills were indispensable. Because of this, only those skilled with various types of tools could survive. The bow being one of the only ranged weapons that they had, but one of the most efficient ranged weapons that they had, it was one of the primary weapons used for conquest.
The bow is made from 3 pieces of wood, each identified in different layers of the bow. The 3 layers are birch frame,
a rigid structure that surrounds the bow, in this case made from birch bark,
horn or bone,
found on animals such as cattle and goats, but depending on the region that the Mongols conquered, the type of horn varied,
and birch bark.
Coming from a slender, fast-growing tree that often has peeling bark, it was used as the primary material for the bow.
The bow also contains a layer of sinew,
a piece of tough, fibrous tissue uniting muscle to bone or bone to bone, commonly called a tendon. The Mongols preferred to use deer sinew for their bows.
And fish glue,
a gelatinous substance obtained by boiling skins, fins, and bones of fish. First, the bowmaker saws and chisels the birchwood and horn into 3 small pieces. Together they will make the frame for the bow. The fish glue is then applied to the wood, keeping it attached to the horn. After the wood is stuck in place, the next step is to wrap the bow with sinew, ensuring that the bow stays intact. Then, strap both sides as shown, but only tie one side. Bend the bow all the way back and tie the other side.
Now you have your bow!
This enabled the bow to have a lot of power. To give you an idea, the English longbow had a draw weight of 70 to 80 pounds, while the composite bow had a draw weight of 100 to 160 pounds. This meant that the English longbow had a range of about 230 meters, while the Mongolian composite bow had a range of over 320 meters. There have even been some ancient carvings saying that the Mongolian composite bow have hit targets around 536 meters away. This means that the Mongolian composite bow was the most powerful bow around that time. Now that we know how a bow is made, let's look at how a bow works. As a person draws the string of the bow, the tension of the string increases, and the bow bends back. The energy is then converted into kinetic energy upon release of the string, and that accumulated tension gets transferred right away to the arrow, forcing the arrow to leave the bow at great speed. If we were to compare a person throwing an arrow to what a bow does to project the arrow, it is quite fascinating. While a human can only throw a bow with instant force, A bow can store and accumulate those forces exerted by a human and then release them all at the same time, which allows humans to shoot the arrow faster than just throw it. The further you draw back the string of the bow, the more force you will need, and also the farther the arrow will travel. According to Hooke's law, deformation of an object is proportional to the force causing it. The force you need to draw gradually increases as you draw the string, as you can see on the picture on the right.
The physics of the bow.
The main goal in archery is to try to get the arrow airborne, and to try to achieve great lengths and accuracy, therefore hitting the target that you're aiming at. Earlier we said that the bow stores the forces exerted by the person. This means that the initial velocity of the arrow would be this.
F is the force exerted, D the draw length, E the efficiency of the bow.
But to make things simple, let's just say that the efficiency of the bow equals 1. So it's going to be just FD over 2. We know that the formula for kinetic energy is 1/2 mv squared. To make things easier, this is approximately congruent to the force given to the arrow in this case. The velocity of the arrow, if we solve for v, would be this. Ignoring the air resistance, since it's way too complicated for us, this is how the arrow would fly using some trigonometry. First, the arrow begins to fly at a certain velocity with a certain angle. Here, Vx represents the velocity going horizontally, and Vy represents the velocity going vertically. As it gets the gravitational force from Earth, Vy will eventually be 0, which is when the arrow reaches its highest point. After that, Vy will increase downwards, which will make a parabola shape of the arrow traveling. While this is all happening, Vx maintains its velocity from original angle, which means it's constant according to the law of inertia, and just to make sure we are ignoring the air resistance. The time of the arrow being in the air can easily be calculated using only the formula, which is this: T equals 2 Vy over g, which is a derivative of the acceleration formula, V2 equals V1 plus AT, where A is the acceleration and T is the time. The multiplying by 2 is because the time also includes the bow going down, not only going up. Since we got the time, now we can get the actual distance of the arrow traveled and the height of the arrow flying. Distance would be time times original velocity, which would be Vx times t. Height, using the formula we learned in science class, would be 1/2 gt squared, of course ignoring the air resistance.